Hey folks, welcome to the NCEA Level 2 Maths probability paper from 2019. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering this question. So without further ado, let's get started. Alright, so with question one, now I hope you guys actually have the actual exam paper with you, because there is quite a bit here that we kind of need to cover here. So question 1a is asking for, use table 1, it's table 1, I've got the table 1 there, to find the probability that a student randomly chosen has a school bag weighing more than 10 kgs. So we're actually looking for more than 10 kgs, so that's going to be 10 kgs. So what we're going to do is we are going to have to add up all of these numbers because they are all actually above 10 kg. Alright, so what we're going to do here is we're going to actually add up these values. So we've got all of these numbers. I'm just going to punch them into the calculator. So we've got 5 plus 4 plus 2 plus 4 plus 1 plus 2 plus 1 plus 1 plus... No, I did it too fast. Plus 2 and plus 4. All right, there we go. That green part actually adds up to 30, and we've got 558 plus 413. That is 971 in total. So this is where the 971 comes from. That's the total. And then we've got 30 out of 971 where the bag actually weighs more than 10 kgs. So we could leave this as a fraction, or we could just do this and leave it as a decimal place as well. So 309. Now in some cases you might have to actually answer it in percentage. Just be aware of it. In this case it's asking just for the probability. Part 2 is we're looking for is male and has a school bag weighing 2 kgs or less. So we're looking for a male and 2 kgs or less. So that's pretty much all of this. So we've got 971 students altogether, and then we've got 24 plus 59 plus 60. That's going to give us 143. So 143 out of 971, and that's equal to, divided by 971, that's going to be 0.1473. And I just realized that I haven't actually given grades for the first two questions. So the first question is actually worth an achieved, and the second one is also worth an achieved. Okay, so let's go to part B of this question. So we've got a claim here that female students in New Zealand are more likely to have a heavy school bags than male students. So heavy school bags is when it's over 5 kgs. All right. So I've got to add up quite a bit of numbers, but I think I might actually do this. Let me just get rid of all of this. So firstly, for over 5 kgs, I actually need all of these numbers kind of added up. So what you can do is, you can sit there and add them up, or what you can also do is you can actually do something like this. So I'm going to look at the females first. So if you look at it, we've got 558 females in total. Now what I'm going to do is I'm going to add up these numbers here. Less numbers to add up. So 26, 58, 85, and 92, 89, and 67. That's giving me a total of 417. And then what I'm going to do is 558 take away 417. And that's giving me 141. So for 141, so that's going to be 141 students out of 558. That's for the females where their bags are actually over 5 kgs. Then I'm going to do the same for the males. So out of 413, I have to subtract the total of these numbers from 413. So I've got 24 plus 59 plus 60 plus 79, 47 and 46. That's giving me 315. And if I do 413 minus 315, that's going to give me 98. So at the moment I've got females as 141 over 558 and then males as 98 over 413. I might as well, because what I need to do is I need to do the relative risk. So I'm actually going to take the probability of the females with over 5 kgs divided by probability of males over 5 kgs. So I'm going to take 141 over 558. So 141 over 558, and that's going to be divided by 98 over 413. So I'm getting a fraction here, and what you can do is click on S to D and convert that to a decimal. So that means our relative risk here is 1.065. Now, does this provide evidence to support this claim? Unfortunately, it's only 6% more. Like, this statement, whenever I look at it, I go, it's more likely. That means we're quite sure about it. But in this case, it's only like 6% above. So what we're going to say is just write a little statement first off. So this means that females are 6% more likely. Now you might be wondering, hang on, where did I get that 6% from? So remember, I always use the GST example, okay? Think about it like this. When we did 15% increase for GST, we would multiply it by 1.15. So that 1.15, the 0.15 is actually the 15%. So in this case, we've got 6, so that's 6%. So basically what we're saying is that the females are 6% more likely to have a heavy bag. So we've done the relative risk calculation, and then we've got to consider other statistical considerations to support your answer. So as I was saying before, the relative risk is only it's only just above 1. So the actual difference might actually not be significant enough. So yeah, just something to keep in mind, that because it's such a low number, that the actual difference may not be significant. So yeah, so that's pretty much it for this question. Grades wise, one risk calculated correctly. Yeah, so in the schedule there, what we've got is we've got some people, we might have some people that might have actually included the 5 kgs. And so they got a slightly different risk. But so in this case, if you do the risk correct, so that's going to be an achieved, one risk correctly calculated. But correct relative risk is actually a merit. So actually not incorrect. This right here ends up being a merit. But I think if you make a mistake, you can potentially get an achieved. This is a T2 question. So we've got correct or reciprocal relative risk, and explanation is T1. So this here is an E7, and then the last part here is an E8. That means you can potentially get 8 points for this one question. Let's go to the next one here. So the next question, what we've got is referring the shape of the distributions in figure 1, blah, blah, blah. Describe clearly how this distribution is different from a normal distribution. Okay, so this is fairly simple. Normal distribution has to be symmetrical. This distribution is not symmetrical. So I would say this distribution is not symmetrical. And the other thing also is this is actually not bell-shaped. Well, there's a bit of a skew to it, but then you can't really have negative values of weight. So you can kind of say that, yeah, it's not symmetrical. But actually we can write it like this, because normal distribution is symmetrical and bell-shaped. That's pretty much enough. I think describes a lack of symmetry is achieved. So achieved is if you actually say that it's not symmetrical, and if you'll get a merit if you actually say that normal distribution is symmetrical and bell-shaped. It's incredible that you could actually get 5 points for this question just from basic understanding of normal distribution. Because if you get a merit grade, you get 5 points. Yeah. Anyway, let's go to the next question. C2 is give 2 reasons why it's unlikely that the school bag weights would be normally distributed. Now, this is kind of like, this is where you kind of get into the context of some of these things. But I'm going to go right to the top there, because we were given the mean weight of the bags, which is 4.1 kgs and 4 kgs. So if we go back down here, so there are a couple of things that we can talk about why it's not normally distributed. All right. So there's a few points here that you need to kind of consider here. So the first thing is, your mean is 4 kgs. Your mean is 4 kgs, but if you want the distribution to be symmetrical, so distribution to be symmetrical, because normal distribution is symmetrical, you need negative weights, which is not possible. Negative weights for bags. So that's one reason. Another reason would be like people that bring sports gear. So we could actually have like some individuals, some students carry more than others. Carry more. Example, sports gear, or sometimes people bring heavy laptops versus no device. So there's that to consider as well. So you can kind of get creative in how you actually write this particular point, because what happens is that when you bring heavy gear, it actually drags the tail to the right side, because that's where the more heavier stuff is. So that's something to keep in mind. Also, like if you think about it, a lot of folks have quite light packs, because, and again, you can use the example of like, right now everything is on device, so they don't really need to bring lots of textbooks. So that means that their bags are going to be in the lighter end. Light packs due to devices. I don't know, I'm just kind of throwing ideas out there. Due to devices and no books. Yeah, so there's a few things that you can kind of get creative here. Now, in terms of, actually, no, I'm going to come back to this. Light packs due to devices and notebooks means there will be more data to the left. And then, so extended, this one I need to say extended tail on right. So grades wise, I'm looking at this, like, I think if you talk about symmetry with like one reason, and you talk about symmetry, then you could get a merit, or you talk about two reasons, but you just talk about it. Now, for the excellence, you need to give two reasons and consider symmetry. And I think that should give you an excellence grade for this question. Awesome. That is question 1. All right, folks, on we go to question 2. Question 2, what we've got is we've got a normal distribution question. We've got a mean of 450 and a standard deviation of 35. And working on a diagram must be shown. Correct answers alone will generally limit grades to achievement. Wow. I've not seen that before. This was one of the older papers. I guess this is what they do back then. All right, that's fine. So we're going to do between 415 and 520. So what I generally tend to do is, like, I always like to draw diagrams for these types of questions. So I'm going to draw a normal distribution curve. Let's draw that a little bit better. Yeah, that's the closest we can get. No, come on. There we go. So that's my normal distribution curve, where the middle is the mean, so that's 450, and then the standard deviation is 35. Now it's asking for 415 and 520, so 415 is going to be there, 520 is going to be there. Now, one thing that I would say is, I would always say just sketch the diagram, and then I would actually write the Z values for this. So how do I do that? So I'm going to put down probability of 415x to 520. Now, if you don't have a calculator, graphics calculator, or the FX 8200, then you've got to do this manually. So to do this manually, remember that Z is equal to X minus mean over standard deviation. So in the calculator, I'm going to do the first part, but then after that, I'm going to do it straight in the calculator. So I've got fraction. I'm going to do 415 take away 450 divided by 35. So this gives me -1. And because I'm now working with Z values, I'm going to change that to Z. Then I've got 520, and that's going to give me 2. So we've got -1, between -1 and -2. So to do this on the just manually, what you have to do is, we've got the values between -1 and 2. Now, remember that normal distribution is actually symmetrical. So I'm just going to go down to 1. So that's 3413. So if it's -1, it's also going to be 3413. So if I go back to my working out here, this area is going to be 0.3413. And then for this area, I'm going to go with 2, which happens to be 4772. So let's go back here, 0.4772. So on my calculator, I would go 0.4772 plus 0.3413. That's going to give me a value of 0.8185. Now this is if you don't have a graphics calculator. If you do have a graphics calculator, then you would go into menu, go into stat, distribution, normal, NCEA. We're going to go lower as 415, upper as 520, standard deviation is 35, and the mean as 450. And if you go down, you can actually see draw, and there you go. So you can actually just copy your Z values from here. So I would just copy Z value of -1 and 2, and then in my next line I would just write down equals to 0.8186. Sorry, didn't realize it was in red, but 0.8186. Now if you're like one decimal off at the final answer, that's all right. I mean, you'll still get a grade of achieved for that. So this question, yes, it is actually just worth achieved, and I know it took a long time to explain it because just wanted to kind of cover the people that don't have a graphics calculator. All right, going into the second one, we're looking for less than 400 grams. So if we're looking for less than 400 grams, we're gonna again do the same thing. We're gonna do a quick sketch where this is 450 and standard deviation is 35. We're looking for less than 400. So 400 is going to be there, and the zone we're looking at is this one. So we're going to write down probability of X less than 400. And we're going to do the same thing there, but this one, folks, I'm just going to kind of fly through. So I'm going to go back to the stat mode. My upper limit is 400, and my lower limit is going to be -1 times 10 to the power of 10. And I like using this because it just makes it really easy. And what I'm also going to do is I'm going to draw this so you can kind of see it. So notice how it says lower is -2.8 blah blah blah. We're going to write this as probability of Z less than -1.428, and then that probability is equal to 0.0766. So again, this question will be worth and achieved. Now you might be like, well, okay, quick crash course, really quick crash course. So what you would do is you look for positive 1.428, and the way you would do it is like you would go track 1.4 here, then that's 1.42 because that's in 1.42. Then you got to go down to 8, which is 11, and you got to add 11 to the last two. So you're going to get 0.4235. And then you got to go 1 minus 0.4235 because the 0.4235 is this part here. And then you would go 0.5 minus 0.4235 to get the 0.0766. Cool. Let's go next question. Next question we have is company rejects the heaviest 10% and the lightest 15% of all plastics made. So what that means is that we're going to have to draw another graph here, and we're going to have 2 points here. So the lightest 15% and the heaviest 10%. So that means the yellow part here is going to be 15%, and the heaviest 10% is going to be this part here. Now, so this is 0.1, this is 0.15. So the way you do this is that you've got to figure out what the Z value is for 0.15, and then you're going to rework it. But if you do have the calculator, I heard someone say the other way, this is like pay to win, and I'm not surprised they said that. So what we're going to go is go into distributions, normal, and then we're going to inverse n. So at the moment, we're going to go with our left tail, and we're going to put left tail as 0.15, and standard deviation and 35, mean is 450. That's all stored before, and we're just going to go solve it. And what you'll notice is that you actually get 413.724. So I wouldn't just write the answer. What I would do is that the hack I have is this. Instead of putting, I would actually put 1 and 0 first. All right. So what this does is we can basically say probability of x less than, we're going to call this, I don't know, x1 and x2. x1 is equal to 0.15. Then we can say probability of z less than whatever the value is, right? And I don't think it'll be x1. It'll be like whatever z1 is equal to 0.15. And then what I would do is I would just write down z1 is equal to negative 1.036. And then if z1 equals to that, then we can say z1 equals to x1 minus the mean over standard deviation. So you're going to get negative 1.036 equals x1 minus 450 divided by 35. So now I would just write down x1 is equal to, I'd go back to the calculator and I'd put down 35 and 450. And that's going to give me 413.725. No, they're just going with one decimal place, 413.7 kgs. And I'm going to pretty much repeat the same step here. So probability of x greater than x2 equals 0.1. Then probability of z greater than z2 is equal to 0.1. z2 is equal to, I'm going to go back here. I'm going to change this to right tail now. Put that as 0.1, 1 standard deviation, and 0 as the mean. And that's going to give me z2 as 1.281. So z2 equals x2 minus the mean over standard deviation. z2 is 1.281 equals x2 minus 450 over 35. And then I can just say x2 equals, but I'm going to just put that in the calculator. And that's going to give me 494.9 kgs. So basically the acceptable range is between 413.7 and 494.9 kgs. Now, I know I kind of mixed things up here with doing it manually. Like doing it manually, you would actually have to go back to the table and work backwards. So when we're looking for 0.1, you actually have to go here and see, notice how this is 0.1, 0.1, 0.1, no, 0.15 first. Actually, no, I just realized something. It won't be 0.1 because in the table, what you have to do is you have to find the inverse of this. So this is 0.4. So you have to go into the table and look for 0.4. And if you look for 0.4, it's somewhere here. So it's 1.281. And if you go, we've actually got 1.281 there. So that's just going backwards. It's a bit of practice, but it can be done. So grades wise, this grade is actually worth one of the end of points of the range correct. So if you put just the answer only, you get achieved. With no working, you're only going to get achieved. But if you put this kind of working out, then this changes into a merit. And if you get one of the ranges correct, then this will be an achieved. Okay, so next question, what we have is next plate of the company. Plates also have a mean of 450, so that's the same. However, the standard deviation of the plates is higher. So basically, all it means is when the standard deviation is higher, that means the weights actually have a much bigger variety. So we can say something like, what is this? Oh, it's handmade plates. So she's actually making plates. Yeah, so we can say that Taylor is actually less consistent because of her standard deviation is quite large. That means there's quite a bit of variety. Plate weights have a variety. So yeah, that's pretty much it. I don't know what else you can write in this. Grades wise, I cannot believe correct interpretation is worth a merit. And achieved is unclear or contradictory comments with some validity. Yeah, it's another one of these questions where basically I've just realized you could have answered 2 questions and you could have got 10 points in this question, in this paper, and passed. Basically this question, which would have given you 5 points if you wrote it correctly, and there was that other one up in the top there. If you had written that right, they would have given you another 5 points. That's 10 points, and you've pretty much passed the paper in like 2 minutes. All right. Going to the next question. So for Taylor's plates, more than 75% weigh than 400 grams. So we're going to put down a little diagram here. So we know the mean is 450 and we've got 400, and all of this yellow part is equal to 75%. So that's going to be 0.75. What is the range of possible values of the standard deviation of the weight of Taylor's plates? Okay, so the first thing that we've kind of know here is we need to figure out what the weigh more than, for Taylor's plates, more than 75% weigh than more 400 grams. Man, they kind of tricked us in this because they actually say more than 75% weigh than 400 grams. That means it could be 76, it could be 78, it could be all the way up to, well, yeah. So if that's the case, then it could be 400, but it could be also anything before that. And so we've got to kind of figure out what the standard deviation is going to be. So that basically means that we want that to be 400, but then that yellow area could be 0.75, could be 0.8, 0.9, we don't know. So first thing what we're going to do is, if we think about it like this, so probability of X greater than 400 is actually greater than 0.75. So that's the way you kind of need to kind of keep that in mind, right? So the X greater than 400. So next, if you look at it, so we can say that probability of the Z value greater than the Z1, whatever that's going to be, is also going to be greater than 0.75. So looking at it, we need to figure out what that Z value for 0.75 is, right? So we're going to go back and look up 0.25 first. And the way we're going to do it is go into distributions, go into normal, inverse, let's go right, and then go 0.75. So I've got right tail is 0.75, standard deviation is 1, mean is 0. And basically that's giving me a Z value of negative 0.67. So keep this in mind. So this right here is negative 0.67. Now the Z value has to be less than that. And the reason is because in normal distribution, like when we think of like normalized, you've actually got 1 and 0. So if you want to have something above 75%, then the Z value has to actually be moving that way. Let me just show you again. So this is when it's normal distribution, right? Because if the mean is 0 and the standard deviation is equal to 1, and we've got this value which equals to negative 0.67. Now we know that in this case, the yellow part is actually 75%. But we said it could be more than 75%. That means if it's more than 75%, so let's say if it's 80%, right? If this is 80%, then remember that the Z1 is negative 0.67, that's actually here, but the new Z value is actually moved. So your Z value has to be less than negative 0.674. Let's actually go 4 decimal places. 45. So then what we can then say is we can actually put down that X minus the mean over standard deviation has to be less than 0.6745. So that's all I've done so far there. I've just replaced the Z with the formula. Now I know that this is going to be 400 minus 450 divided by standard deviation is less than negative 0.6745. Then I'm going to get negative 50 divided by standard deviation is less than negative 0.6745. Cross multiply, and I'm going to get negative 0.6745 theta. And here comes the kicker, people. Like when you divide by a negative number in an inequality, you have to actually change the change what do you call it, the standard deviation. So we're going to go negative 50 divided by negative 0.6745. And so the sign now switches, and we've got standard deviation has to be less than whatever this value is. So we're going to go into our calculator and go into just your normal run menu. And we're going to do negative 50 divided by negative 0.6745. So that's going to give me a standard deviation. I'm just going to write it down properly. The standard deviation has to be less than 74.12 for this to actually work. So if you look at the range of possible values, we could actually have 35, because that was her original standard deviation, and that's going to go all the way up to 74.12. So folks, grades for this question, correct Z value found is 6745. That's going to get you an achieved. A merit is not doing it as an inequality. You're just putting it as equals. Then you could actually get merit. So I'm guessing you probably get a merit here if you don't use the inequalities. If you get the range correctly, then you are looking at an excellence for this question. All right, so next question. So next question is two plates were randomly selected and they both weighed over 520, blah, blah, blah. Assuming the weights have the same normal distribution as the company. Okay, so our mean is 450 and standard deviation is equal to 35. So I know I've done this once early, so this one I'm going to kind of use the calculator, folks. So distribution, normal, NCD, and I'm looking for 520 and above. So 1 exponent 10. Standard deviation is 35. Mean is 450. So that's going to give me a probability, and I'm going to put this down here, x greater than 520. Probability of z greater than lower is 2. So that's 2, and then which equals to 0.0227. So that's probability for one of them. So if you want it for two of them, we're going to go 0.02275 multiplied by 0.2275. Whatever that is. So I'm just going to square that. So that's going to give me this number here. Yep. So we're going to write that as 0. How many is that? 4. So 1, 2, 3, 5, 1, 7. So if you look at this, this is roughly 0.05%. Yeah. So that's what we're looking at. Grades wise, this first part is actually worth achieved, and then correct probability is actually a merit. Okay, next question. What could your answer do to part D1? Okay. So for this question, basically the probability from D1 is actually quite small. So that's the first thing we need to keep in mind. And if it's that small, then Eddie's plates, these are some of the things that could potentially happen with this plates. So the first thing is that it could have a higher mean, because if the mean was the same, the chance of 2 over 520 grams is actually very, very low. Number 2 is increased variation, but have the same mean. Number 3 is he might have a higher mean and increase. I think we already talked about this. Higher mean and increased variation. So, and also the last thing is that his distribution might not be even normal. Because if it's not normal, then finding probability is actually quite hard. I don't think I've done justice for this particular question. I will check out the schedule here. Feel free to have a look through it and see if it actually makes sense for you. Because yeah, now I always find these word ones quite challenging. One of the reasons is clearly stated. Yep, that's for a merit. A student cites that low value of probability of 2 plates greater than 520. Yeah. And one of the reasons is clearly stated. So really only looking for like one reason clearly stated to get an excellence. Wow. There we go. Nope. I don't think I would have got an excellence from this. I know I would have got an excellence from the previous question with finding the standard deviation. Anyway, folks, that's question 2. We move on to the next one. All right, folks. So for question 3, what we've got is winning game A, 0.6, 50 cents to take part plays game A twice. Okay, so which means could win game A, which is 0.6, 0.4 is lose, win and loss 0.6, 0.4, win and loss 0.6, 0.4. Okay, so if the player wins both times, they receive $2, so that's going to be $2. If they win only once, they receive $1. What's the probability that the player receives $2? So that's going to be 0.6 times 0.6, which is equal to 0.36 or 36%. That is worth and achieved. Question 2, what's the probability the player receives $1? So that's going to be 0.6 times 0.4 plus 0.6 times 0.4, which equals to 0.48 or 48%, which is worth and achieved as well. Now, I know I kind of went through that fast. 0.6 and 0.6 for $2 is this part here. And then 0.6 times 0.6 for the $1 one. It's basically this branch plus this branch here. That's what we're doing for the 2 achieved questions. Okay, so part 3 of this question, Kim decides to play this game 100 times. Junin says that Kim will profit exactly by 110. What are the errors in Junin's statement? Okay, so plays it 100 times. Okay, let's have a look. So basically for this question, they've given like 4 different answers, and I'm going to do the first one. So if you play 100 times, there is 36% chance of winning $2. So that means 36 times 2, because 36 times you won $2, that's going to be approximately 36 times, right? So that's going to be $72. Then there's 48% chance of winning $1. So that's going to be 48 times 1, which is equal to 48. And then if you do 72 plus 48, you are going to get $120, which is approximately, you know, total consistent with 24%. Yeah, I would say it's about $120. So it's pretty close. But what are the errors in this statement? I guess the error is that he won't profit exactly by $110. It could be $120, but again, this is a probability. So he might win it or he might not win it. This is just an expected one. So you can't really say will profit exactly by 110. So this is one point that you can kind of elaborate a bit more. Bullet point number 2 is that you are actually, how much are you spending? Like you're playing the game 100 times, and I think it was 50 cents per game. Yeah, 50 cents right at question 8. So it's actually going to cost him $50 to play the game. And if we look at the probabilities from the previous one, theoretically he will make $120 profit, right? But he spent $50 to play the game, which means he's only not profit, sorry. He makes $120, but he spent $50 to play the game, which means theoretically he's probably going to make close to $70 roughly for profit than actually $110 profit. So again, that kind of says that his statement is actually incorrect by Juyun. And of course the third, so I would talk a little bit about the 120 take away 50, which is only $70 profit. That's the expected one. Number 3 is, you know, it is always a game of chance, and you never can predict that you would get something exactly that happens the way it happens just because of probability. So keep that in mind, and you might actually talk about that. Always a random chance, or variation if you want to call it. And also number 4 is like experimental probability. So this is experimental probability. This is always going to be different than the theoretical probability. So you might actually elaborate on that theoretical probability. You might elaborate on that a little bit more in your explanations. And so basically you are going to need one reason for achieved and a second reason for merit. All right, let's go to the next question. All right, so for this question here, we've got to kind of do a weird probability tree, because what's going to happen is, let's say they play the game, right? So they won 2 games, or until they've actually played a game, total of 4 games. So let's say we start like this, win-loss. Now what's going to happen next is that's going to become win and loss. So this is a second game. Second game could be win or a loss. So that's game 1, game 2. Now with game 3, because the first branch, they've already won it twice, they don't need to go any further. So then this is going to be win-loss, win-loss, win-loss. So this is the third one. So we've got win-win, win-loss, win. So the fourth game, because I'm looking at this now, hang on. So he's already won twice, so that branch is not going to continue anymore. So from there, we're going to go win or loss. And this one is already also completed because that's loss, win, win. We don't need to worry about that. So loss, win, loss, W and L. W and L, and then the three losses, we don't really need to worry about that one because that's going to be a loss anyway. So we don't need to worry about the win loss, but I'm going to put that in there anyway. So basically the branches we're looking for is win win, and then we've got, I'm going to see how many colors I get, win loss win, and then we've got win loss loss win, then we have loss win win, then we have loss win loss win, then we have loss loss win win, and I think that's pretty much it. So we've got altogether we have 6 branches that we need to consider. So we've got win, and we've got win and win here, so 2 wins in a row. We've got WLW, we've got WLLW, then we have LWW, LW, LW, LLWW. So altogether we should have 6 branches, and then we know that the probability is either 0.6 or 0.4. So for the first one, we're going to get 0.6 times 0.6, 0.6 times 0.4 times 0.6, 0.6 times 0.4 times 0.4 times 0.6, 0.4 times 0.6 times 0.6, 0.4, 0.6, 0.4, and 0.6, 0.4, 0.4, 0.6, 0.6. And if we add up all of those values, we should get the answer that we're actually looking for. So going into the calculator, we've got 0.6 times 0.6 plus 0.6 plus 0.6 times 0.6 times 0.4 plus, I think I kept track of it, 8208. So we are going to get an answer of 8208. So the probability of winning in this game is 0.8208. So grades wise, 1 correct identifier probability calculated for at least 3 games. Achieved. At least 4 out of the 6 probability correctly calculated and summed. So at least 4. So we're going to be looking at a merit. And then final grade is going to be an excellence 1. Neat question. I love it. Okay, next one. All right, so with this question, what we've got is, I don't know what it is. I'm just going to put this up here. So we've got P as the probability, which is going to be winning the first game. So this is going to be the first game. She wins it. So win, loss. Then the second game that she's going to win is going to be 2P. Yep, that's going to be 2P. And then if she loses the first game, her probability of winning the second game is half her probability of winning the first game. So that's going to be P over 2. It says probability that Zuta wins 1 game or fewer is 0.75. Okay, what's the probability she loses both games? Okay, so the question is actually asking for this. Probability she loses both games. Now this part here, the probability that she wins 1 game or fewer is 0.75, is basically the green branches, they all add up to 0.75, which means the blue branch is going to be 0.25. Because remember, all the branches, they all add up to 1. So the blue branch is P times 2P equals to 0.25, which means 2P squared equals to 0.25. P squared is equal to 0.25 divided by 2. P squared is equal to 0.125. And P is equal to square root of 0.125. Click on that. So that's going to be 0.3535. So if P is 0.3535, now I only have one issue. Hang on. Oh, this is going to be, okay. So this loss is going to be 1 minus P. And then the second loss is going to be 1 minus P over 2. So the probability she loses both games, which is loss, is 1 minus P times 1 minus P over 2. And because we found out that P is equal to 0.3535, I am just going to put this straight in the calculator. So I'm just going to go 1 minus answer, because that's what my P value is, multiplied by 1 minus answer, but then divided by 2. Convert that. So that should give us an answer of 0.5321. So grades wise, probability tree set up with correctly with x or 2x and x over 2, which we've done. That's going to be achieved. Getting 3536 is a merit, and the final answer is actually worth an excellence. Love these types of questions, I'm not going to lie. Grades wise, what is it? As you can see, cut scores, 8 is for achieved. Merit is actually only 14, so you get a couple of merit questions. It's actually easy to get merit in this paper, to be honest. Excellence, a little bit on the 20 side, so that's not too bad. 20 is what we kind of expect, and so yeah, not bad. All right, folks, so that's pretty much it for this paper. If you do have any questions or comments, just drop it in the comment section below. As always, I know my explanation for some of the questions, especially the wordy ones, absolutely are terrible. So if you do have a better explanation, feel free to drop it in there. I'm more of an algebra person, so I do like those questions at the end with the probability where, you know, you got to try and figure out X. That's more my jam. But anyway, that's basically it. Good luck for your exams, and yeah, stay tuned.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.